Yes, we've got another worksheet that we're going to work on. I told you this week was going to be nasty, right? We are behind. We got stuff to do. So now that we sort of have a little bit of a handle on why elements form ions and what it actually means to be an ion, right? What does it mean if it has a +2 here? It's a different number of protons and electrons, right? What we're really interested in is how atoms combine. How do we make compounds? When sodium and chlorine come together to make sodium chloride, what actually happens? How does that occur?
A reaction.
There's a reaction, but what does that mean, a reaction? Well, as I referenced last period, some elements need to gain electrons to become like a noble gas. Other elements need to lose electrons to become like a noble gas. Magnesium needs to lose how many electrons?
Needs to lose 2.
Needs to lose 2. So magnesium, to form +2 ions, is trying to get rid of 2 electrons. Right? But where do they go?
They go to other atoms.
They go to other atoms. So if magnesium was combining with chlorine, what's chlorine trying to do?
Become argon.
Gain 1 to be like argon, right? So chlorine says, yep, thanks. Give me that electron and I'm good to go. But it only wants 1 electron, right? Magnesium's trying to give up 2. How do we solve that problem? We need 2 chlorines. If we had another chlorine here, also trying to gain 1 electron, then the sum of those 2 chlorines would be able to account for both the electrons magnesium is trying to lose. So when we write the formula for magnesium chloride, we have to show that. We have to show how many of each ion do we need so that the total number of electrons being lost is equal to the total number gained. The way we write the formula for magnesium chloride is MgCl2. We need 2 chlorines because each one's a -1 to balance with the magnesium, that's a +2. Okay? Now because of the things we've put at the top of our columns on the periodic table, we're not going to have to do this whole process here. We're not going to have to write out all the electron configurations every time. Okay? You need to understand that this is why the charges are the way they are. Okay? But to actually figure out the chemical formulas, we can just look at the top of what we've written on our periodic table. Okay? That's what we're going to do. So the first one on your worksheet here says lithium oxide.
Doesn't it say magnesium, oxygen?
This one was magnesium chloride. The first one we have is lithium oxide.
Oh, other side.
Now, we're going to go back and we're going to figure out how to go from a formula to a name next, but I will tell you that for these names, they almost always end in "ide." Look at the first 6 examples. Lithium oxide, strontium chloride, cesium nitride, beryllium iodide, potassium selenide.
Or 8.
If you keep going, some of them end in 8.
That's it.
There's, well, I didn't put any ites on there. Sometimes you'll see ites, okay. But if it ends in "ide," we probably just changed the name of an element to make it "ide."
Carbon.
What element did we change to make oxide?
Carbon.
Oxygen. Okay? So lithium, we're not going to change that name. It's just lithium, so we know it's Li. Oxide, though, came from oxygen. Oxygen turns into oxide.
So
Okay.
do we get the charges from the top of the...
Yeah, now we look at the top of our periodic table. What's above lithium's column?
Hydrogen.
+1. Yeah, hydrogen's the top element, but we should have written above that a +1. Above oxygen's column,
2.
-2. Okay? So we're going to really shortcut things by just looking at the top of our periodic table, or again, we can use the shortcut, well, lithium's got 3 electrons normally, right? The nearest noble gas is helium with 2, so it's got to get rid of 1, making it a +1 charge. Oxygen has 8 electrons, The nearest is neon with 10. It needs to gain 2 to be like neon, minus 2. Okay? Because you're not going to have your periodic table with the charges on the exam, right? You're going to have to remember why those charges are what they are. Okay? Now to figure out lithium oxide, is the 1 electron being lost by lithium going to balance with the 2 electrons being gained by oxygen?
No.
No. So what
Wait,
do you
then,
do?
how does it become, how does oxygen become a noble gas then without,
It gains 2 electrons to be like neon.
oh, so you have to have 2
It's
lithiums.
not become, yeah, this minus 2 means it
Yeah.
gains 2 electrons.
I know, but like, oh, okay, yeah, I see what you're, because you have 2 lithiums then.
Yes, now the only way it can gain 2 electrons is if there's 2 lithiums,
Yeah.
each losing 1 to give it those.
That's what
So the formula for lithium oxide, Li2O. We need 2 of the lithiums and only 1 of the oxygen. So the numbers are exact opposite as we had for magnesium and chlorine. Make sense? All right. Try the next ones up to magnesium sulfide. Stop there. If you're totally confused, raise your hand. I'll come help you out.
It's in the second one. Plus 2.
Yep.
So SR plus 2.
So now, are these going to be balanced? Strontium's trying to lose 2, chlorine's trying to gain 1. Is that going to work? No. What do we need more of? Strontium or chlorine? How many? Which is right. I would even just write another Cl minus. Oh. Just try to write it.
What is it?
Okay.
SR
So now we're
plus
balanced, right?
Chlorine. Chloride is chlorine, right?
Yep. Chlorine's name turns into chloride.
That's going to be minus 1.
Okay, so you gotta have your.
Wait, can you have more of the Mr. Bull?
You can have more of either one.
Oh, okay.
Right.
So then it's going to be SR2.
Right, a plus next to that.
SR,
We're gonna have
just
a negative.
SR2,
Plus 3 up here.
and then O,
Plus
no,
or
no,
minus
O, and then
4.
CL2.
Plus or minus. So right, plus 4 right above.
SR2.
It could be either.
No, you don't.
Okay. Minus 3. Minus 2.
Oh, okay.
Okay. So strontium. Where's strontium? Okay. So it's simple as SR. So we're gonna write SR. What charge is strontium?
Oh, that's 50. So that's
Oh, 2. Plus 2. Okay. Chloride. Where's chlorine? CL. What's the charge?
That's 55.
Oh, okay. Okay, so are those charges balanced?
Negative 3.
We need more.
Yeah, exactly. CS3 and then whatever's missing here for next week.
Now are they balanced?
Did you get CL2?
What is this?
Because there's negative 1.
Beryllium.
Oh, no, we read them together.
That's plus 2.
It's the second one, B.
Yeah.
CL is 1. What is that? So it's iodine.
How many chlorines we need. So we don't write the charges. Another important thing to keep in mind, when I write the formulas, I don't write the charges anymore. We don't care about the charges when we write the formula. That's going to get confusing if we have all that information. We just want to write how many of each ion is needed to give us a balance between the total positive charge and the total negative charge. I'm going to go 1, 2, 3.
2 iodine.
Yep.
Where is it?
So B, B, I,
Because
2.
this was written in Britain and this was written in America.
Oh, I found it.
Oh, 2 different spellings. Tomato, tomato. It's the same spelling.
Mr. Bowl,
What up?
I need help.
I know you do.
Okay, what?
K plus 1.
Where's Sylvie?
It has to be. If strontium's a plus 2 and chlorine's only a minus 1, we need
Where?
What number?
Oh, I wouldn't have that.
Where's
Chlorine is not
It's
for
VE, bro.
negative 2.
Chlorine forms negative
It's
1.
4.
No,
The 2 is telling us we need 2 chlorine.
So you need.
I got
So if we have 2 negative ones, that'll balance with the positive 2.
Wait.
Wait,
Potassium.
isn't it K2?
Yeah.
But
Yeah, cesium.
positive.
Yeah, cesium, it's the same element, it's just spelled different.
No, it's K2.
Oh yeah, it's taken.
Yeah.
Oh my god, I tried one.
Yep. No, that's nickel. Nitrogen's just N.
Wait, why is it?
Nitrite is just nitrogen, N.
That's what I just said.
How much is evil?
Nitrite is nickel.
Are you like pretty much trying to like make it equal to 0?
Yep. That's exactly what we're trying to do. When you add up all the charges, it's
Is it the same thing? Oh, wait.
Why do you guys put K2? Potassium selenite.
Because the K is only 1.
Yeah, but SE is 2.
Yeah.
So what
Look at the first example.
Wait, which
Same thing. Basically the same thing, just different elements.
Yeah.
Wait, so you add 2 for it? Number 34.
the minus 2 is bigger than the plus 1, right?
Yeah.
So we need more of the plus 1s to balance with the minus 2, right? So we actually need another potassium, another plus 1. So we added plus 1, and minus 2. It was getting
Hey, Mr. Bull.
What is easy?
Mr. Bull.
Then you do the same thing.
What's the difference between sulfide and
Now the
sulfate?
negative is smaller than the positive, so I need more negatives. I need 2 ions to balance with Yep. Nice.
Wait, Mr. Bull, what's the difference between sulfate and sulfide?
Well, I'm gonna do
I
that
finally
next.
got something.
And when you're done with magnesium sulfide, 'cause I want to talk about the next one together.
Is it gonna be 0?
Huh?
Zero.
0 of each ion?
Yeah.
Oh, you have to have at least 1 of each ion. Remember, if it's invisible,
One.
get it? 0.
Alright, so it's gonna be 1 of each.
Okay, everybody take a look.
I'm so smart.
Magnesium and sulfide, do we agree these are the ions?
Oh, yeah.
Okay, how many of each do we need to be balanced?
None. Oh, you're good, you're good.
1 of each.
One of each.
So MgS is the formula.
Yeah.
Okay.
Nope.
Now the next example says magnesium sulfate.
Isn't that the same thing?
No.
Okay.
If it ends in anything other than "ide," it's what we call a polyatomic ion. Poly means many, atomic means
Atomic means
atoms,
Oh yeah.
and ions mean something with a charge, either more electrons or less electrons. So we're talking about many atoms together that have a charge, polyatomic ions. Now the reason I have to give you guys periodic tables tomorrow is you do not, on the back of your periodic table, have a list of the polyatomic ions. But on the final exam, some of you do, yes. Some of you, I gave you the last year one.
Is it this one? Like this?
Does it have a list of polyatomic ions?
This one is the laminated ones.
Laminated ones do. Okay? This is the list you will get on the final exam. Okay? Look at all these polyatomic ions. Most of them end in 8, some end in "ite, and there's actually 2 you really got to be careful for. Look at this one. Cyanide. It ends in "ide, but it's a polyatomic. How are we going to know that? Well, if I say to write the formula for magnesium cyanide, you're going to be looking a long time to find cyanium.
Wait, what?
There's no such thing as cyanium. So if you're looking and you don't find an element that would match that name, it's probably polyatomic. Cyanide is one of them. There's another one that ends in "ide" on this one. Hydroxide. Okay? That's OH minus 1. Again, there's no such thing as hydroxium. It's actually a polyatomic of hydrogen and oxygen. Those are the only 2 ides on this list. So I will have you highlight those again. Ooh, look at you! Smarty pants.
Wait, what?
There's another polyatomic ion that ends in "ide that is not on this list though. What is it? Peroxide. Yes. Peroxide is O2, -2 charge.
What's a polyatomic ion?
many atom together
Ion.
with a charge. So if we look at all these polyatomics, it's not just one atom, it's a whole bunch of them. Look at dichromate. It's got 2 chromiums and 7 oxygens. That's a big old clump of atoms. Many atoms put together, but the overall clump still only has a charge of -2.
Wait, so what would sulfate?
Okay, so hold on.
SO4.
Yeah. So magnesium is still magnesium.
Yeah.
Still Mg+2. But who found sulfate?
Me.
Where?
SO and then to -2.
Careful.
SO4.
Oh,
SO4.
Okay.
So sulfate is
SO4.
actually 1 sulfur and 4 oxygens put together.
Okay.
What's its charge?
-2.
-2.
Oh, so you need 8 then.
They're balanced.
Yeah, they're balanced.
+2, -2.
Oh, okay.
They're balanced.
So it's just the same
Wait, then what?
MGS.
MgSO4.
What's the 4 there for?
The 4 is telling you how many oxygens are in this ion. So a sulfate ion actually looks like this. It's a clump of atoms together that the whole clump has a -2 charge.
Okay.
Okay? Now I actually want to do the next one for you guys, with you guys as well. Magnesium hydroxide.
OG -1.
Hydroxide is OH negative.
OH.
What's magnesium?
MG +2.
Mg+2. Are these charges balanced?
No.
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 Negative. You're gonna need one more of the OH.
OH.
Oh,
Of hydrogen.
The
Magnesium
hydroxide.
hydroxide.
We're going to need one more of the hydroxides, one more of the OH ions so
So
that we can balance the charge.
MgOH2.
Now, how do we write this?
MgOH2. Yeah. No, it's wrong, isn't it? Yep, it's wrong.
This is wrong.
So it's on top.
What is the 2 referring to?
Hydrogen.
Just hydrogen if I write it this way. I don't want just 2 hydrogens, I want 2 of this whole thing.
So should we put 2 of the oxygen too?
OH, parentheses, I knew it.
Parentheses, just like in math. I don't want to put O2H2 because that might be a totally different polyatomic ion. I want to say that I have 2 of this thing, so I put the thing in parentheses and put 2 of them. Okay? So, that should be enough for you guys to finish the front of this thing, okay? I will point out towards the bottom there, be careful, you've got iron 3 and iron 2. You see those?
Yeah.
What is the 3 and the 2 telling you?
The charge.
Charge. So those are going to have 2 different formulas, even though they're both iron oxides. Okay, because one is iron with a +3 charge combining with oxygen. The other one is iron with a +2 charge combining with oxygen.
Wait. Why do they do it in Roman numerals even if it's a metal? Like, why can't they just do it in Roman numbers?
I don't know. That's a good question. The history of chemistry. I don't know.
Yeah.
Okay, so here's the thing, guys. We got 5 minutes. We're going to work on this again tomorrow. We're going to work on the backside tomorrow. So try as many of these as you can tonight
And homework.
for homework. We'll talk about the back tomorrow. I'll explain how to do the back tomorrow. Okay?
Is the back the same?
Yeah, oh, for your, you need the polyatomic list.
Yeah.
You can just Google list of polyatomic ions.
Or you can just take a picture of this.
Depends who it's with. Okay, what I want to do right now is stop the video, because nobody needs to see what we're about to do next.